My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 546. In this lecture, I will continue my discussion on backpropagation algorithm. There are some terms that I will introduce you here, and let's walk through each of these steps. There is a term called epoch. Epoch basically means, so one epoch of training basically means input all the points in your data set, once, or you pass all the points in data set once through your neural network. If you pass all the points in data set D, which consists of xi comma yi once, you are passing all the points in data set D, which consists of xi comma yi once, isn't it? If you pass them through network, yes, if you pass them through networks, then it is called epoch. If you pass them 5 times, through the network, it is called 5 epochs. For example, in this, let me consider this particular algorithm. In this, what is my step 2? My step 2, here A, B, C, D. In step 2, I have A, B, C, D. At the end of each of these A, B, C, D, what do? You finished one epoch, because you are passing each of the points xi in capital D, means training data set, and forward through this, and you are forwarding this through this network, isn't it? Just passing xi, forwarding through the network, computing the next, what you are doing, computing the loss, computing the derivatives, and you are updating the weights. The whole sequence, when you do it for all the points in the data set, it is called an epoch, isn't it? All the points in the data set, it is called an epoch, and you typically run it through multiple epochs. If you notice step 3, it says repeat the whole step 2 until convergence. In the real world, for real network training, you run the model multiple epochs, which means pass the data set through the network multiple times. Then you might wonder, how do you pick each of the points xi in D? How do you pick each of the points xi in D? Just pick randomly one point from your data set, one after the other, and pass it through the network. Compute. After passing through it network, what you have to do? You have to compute L, compute derivatives, and update the weights. So intuitively, if you think about it, what is backpropagation? If you think about it intuitively, backpropagation is, first you have to do initialization, second epoch. In epoch, what you have to do? Forward propagation, compute loss, compute derivatives with chain rule and memoization, update weights in backpropagation fashion, isn't it? We repeat step 2. Till convergence. That's what backpropagation is all about. So if you think about it, we know initialization, one of the standard concept in whole of the optimization. The most important part of backpropagation is chain rule, isn't it? The most important part of backpropagation is chain rule and memoization, because most of the important step is compute derivatives, and to compute derivatives we are using chain rule and memoization, except that forward propagation, computing loss and updating weights, backward propagation, all these are standard stuff. The most important point here is chain rule and memoization. So if somebody asks me what is backpropagation. If somebody asks me what is backpropagation, I would say that backpropagation is basically multi-epoch. In training, we use chain rule and memoization to update weights. Just multi-epoch approach. That's it. That's all backpropagation. This is very important idea in whole of probably in neural networks. Backpropagation is the most important type of algorithm for training neural networks. Backpropagation works if and only if your activation functions are differentiable, because if your functions are not differentiable, for example, take this network itself. This is the network on which we are discussing frequently. If the outputs O31, we get this output O31 from the function F31. Similarly, output O11, we are getting this particular output O11 from F11. You get this output O21, you are getting output O21 from F21. If these functions are not differentiable, if your Fij's are not differentiable, then you cannot use chain rule for updating the weights. So the most important thing in designing backpropagation algorithm is activation functions needs to be differentiable. Otherwise, the whole idea of backpropagation and training neural networks goes to the dustbin. If your activation function is not differentiable for whatever reason, if it is not differentiable, that's it won't work, isn't it? So you need to be very careful to design your activation function in such a way that they are differentiable. If you go through this particular algorithm, passing xi forward through the network, this one is easy. This particular part is very easy. This one is easy, isn't it? And computing L, it is also easy. The hardest part or most time taking part is computing derivatives. This is the hardest part, and updating weights is straightforward, isn't it? Your updating weights is it's a straightforward. Most intensive part is computing derivatives. So whatever activation function you have, if it is easily differentiable, then we can speed up the training of the neural networks using the backpropagation algorithm. So two very important things. Backpropagation works if and only if your activation functions are differentiable, and if you can differentiate your activation function faster, more easily, you can speed up the whole training of the network. It is extremely important concept. I request all of you to go through this particular lecture. I will continue my discussion on backpropagation in my next lecture also, that is in lecture number 547. Thank you very much.